Next, we have our Dr. Krishnashree Achuthan. Ma'am is our Dean of our PG department here at Amrita Vishwavidyapeetham, and she's the head of our Center of Cybersecurity System and Networks, along with Amrita TBI Business Incubator. So, Dr. Krishnashree is an ardent researcher with multidisciplinary interest and holds a PhD degree from Clarkson University, NY. Her area of interest in cybersecurity and governance, mathematical modeling and systems, cybersecurity policies, IoT security, public safety, along with innovation, educational technology, and entrepreneurship. He has also led research teams focused on enhancement of laboratory education through virtual laboratories, and she also holds over 33 US patents and has published over 50 publications in journals and conferences. She has also played an active role in several strategic initiatives for the government of India and served as a principal investor. So it is my honor to welcome you, ma'am, for this session, where ma'am will give us a glimpse and a talk on the roadmap of our cybersecurity programs here at our Amrita University. So over to you, ma'am.
Thank you very much, Purnima. Can everybody hear me?
Yes, ma'am, we can hear you.
Okay, great. So I'm going to just share my screen. Can you all see my screen?
Yes, ma'am, we can see your screen.
Okay, great. So I'm just going to run through various different aspects of Amrita and hopefully give you a flavor for what we do here and what are the important problems we look at, how what kind of achievements this group has got, etc. So so this is our center. Actually, our core vision and mission is to really work with academia and government and industry to really promote and create an ecosystem to pursue interdisciplinary research towards protection of assets and of public and national and international importance, and really provide value-based education, very hands-on skills, etc., to our various programs. So I'm just going to touch first on the important research outcomes from the center. In general, the research areas have spanned across some of the most pressing areas that we find in the industry today: hardware security, system security, network security, wireless, Internet of Things, cloud, cybersecurity education, and we are also slowly getting on to quantum security. And your next speaker will be actually speaking a little bit more detail about that. This is not my work only, so I really would like to acknowledge all my faculty who have contributed to various different pieces of outcomes that I'm going to be presenting today. So let's start with the first area, mobile, embedded, and wireless security. Here, this area is actually a growing area. As you know, the number of devices connected to the internet is just growing in an exponential pace. And the security threats are also quite large in terms due to the open nature of the system and the wireless interfaces in this perspective. And so the capabilities of the attacker also has quadrupled in the past few years. And to circumvent the wide variety of protection already existing in the embedded devices. So we work on various different domains. One is automotive security. One of the most fascinating areas in embedded devices is the automotive domain. And here we looking at various different components like the electronic control circuits, the different standards, networking standards, the control area network, the media-oriented system transport, the vehicle-to-vehicle ad hoc networks, etc. And so this actually lays the foundation to really protect and secure both in-vehicle and vehicular networks. And in the context of in-vehicle networks, we look at actually a hybrid model and anomaly detection in control area networks. And some of this work is already published. I'm actually sharing some of these things that have already come out. And so the audience is welcome to note this down, write to us. We are happy to share. the papers and have more discussions if any particular area seems of interest to you. And similarly, in the vehicular networks, we look at defending against Sybil attacks. This is one of the most prominent attacks in vehicular networks. And so if you look at platoons are vehicles that are arranged in a convoy for facilitating communications in a streamlined manner. And Sybil attacks involve, insertion of malicious codes, malicious nodes, fabricating its identities and impersonating those existing nodes. So this is the primary piece of work here. I may not be able to go into so much detail, so I'm going to a little bit speed up here since the time is short. Next piece of work is again very novel in terms of looking at how much of energy is consumed due to code obfuscation. So if you think of wanting the best of security, it requires various different techniques. But what is the downside of actually making anything more secure? The potential downside of ensuring high security is the amount of resources that are required to actually ensure that security. And one of those resources is energy. And this piece of work actually looks into code obfuscation and required really secure application software from, say, reverse engineering type of attacks. And so we've done a significant amount of work in profiling these energy consumption. And by doing these types of things, you can actually come up with an optimized way to enable security without, say, your phone device completely draining out of battery in the shortest amount of time. And we've done a lot of work looking at attack modeling and mitigation. So the space of attacks, modeling, analyzing its impact on system operations, end users, etc. These are all important areas to make any of the solutions more scalable. Next is a very, very important area called as hardware security. Here we look at physical unclonable functions. Many of you have heard of this. It's a fingerprint in IC circuits, and we use it to identify counterfeit integrated circuits. And they are actually very, very vulnerable to inference attacks. And how do we really do efficient implementation of crypto algorithms also for FPGA? This is the other project that we look at in hardware security. Now, there are several publications that have come out of it. I think if you look at just the PUF, the physical unclonable functions, here we've looked at developing a lightweight hybrid PUF for enhanced security, especially in the IoT world. And then these are also very vulnerable to machine learning attacks, and we've also looked at a combination of how can we really make this resilient to these types of machine learning attacks. Now, lightweight ciphers is another very big area, and this work was done in collaboration with our French partner, University of Grenoble, Paulo Maestri. In fact, the paper is down there, which is local clock glitching fault injection with applications to the ASCON cipher. So here what we do is ciphers are really vulnerable to fault injection and side channel attacks. And so we need to be able to model the impact of these on ASCONs. And that was the primary piece of work here. Let's go on to, I think this is again another piece of work in energy profiling, but for shortage of time, I'll just skip it. Let's look at another topic, energy efficient security. So I was mentioning about how it's so important to conserve resources as we really plan and model, security solutions. And given the lightweight nature of embedded devices, energy efficiency is of paramount importance. Traditional mechanisms such as digital signatures, etc., may not be directly applicable to embedded devices since battery power may really be quickly depleted. So in this regard, we have developed several lightweight crypto mechanisms for secure communications. And in our earlier works, we actually leveraged the hierarchical nature of IoT. And we used kind of the identity-based cryptography because that offers significant benefits over traditional public key-based cryptography identifiers. So in contrast to private key generator, distributing private keys can result in a single point of failure. And that's what is shown in the diagram here. And so we have to designate numerous private key generators depending on the functionality. Say in the case of smart cities, where you want to have connected everything, every place of device, you want to be able to connect them to really function and efficiently control many of these devices. So the entire process of private key generation becomes distributed, and that's the outcome of the work done that was published very recently. In addition, you're also looking at a time-bound key management for IoT and prototype on sensors that are developed in-house, as shown here. So I'll have another slide that just talks about that. So this is a very big area, as the title itself says. Security in cyber physical systems means a lot of things, and we have not actually captured everything here. But if you look at some basic, real, fundamental blocks, we've really tried to look at security module. How can it really be invoked to defend against cyber attacks? Again, powering the security module on or during all times can deplete its resources. So how do you intelligently turn on the security module on and off? And here you look at a decision theoretic approach using Markov decision processes. And so that really helps determine how to invoke the security module. And so we look at the three different states: idle, active, shutdown, to be able to intelligently do this. And the impact of trust is also something that has not been investigated very much earlier. So trust can be classified into direct and indirect trust, and computing trust values and challenging. It's challenging because the varied behavioral characteristics of devices in a cyber physical system environment. So in this regard, we look at a game theoretic approach. So here you see how this center actually has done both theoretical work and very hands-on practical work in terms of developing both devices and also the accompanying modeling solutions and approaches to be able to look at these problems in whole. So many times you can see a singular focus, but our group is really very well structured to be able to look at both sides of it. And the way to validate this game theoretic approach, you do a multi-loop, in fact, unmanned aerial vehicle control as an example system that we took in this purpose. So you actually see on the left side picture of the experimental setup in a multi-loop UAV system, and the modeling that takes off from the game theoretic approaches on the right side. So security in software-defined networks is again a very, very big emerging area. I know this is a busy slide, so don't worry about it. But here, what we have done is looking at software-defined networking. It actually can provide great flexibility to the existing software-based network functions. For example, directing of packet flows, and network function virtualization, which is called as NFV. So that's where we see SDN giving very good flexibility. And the fact is that network functions do pose a lot of challenges in large-scale networks, both inside data centers and also across the wide area networks. So through our work, we're proposing a software-defined network function virtualization. So a software-defined stack over an NFV called as SDNFV framework that expands the capabilities to help manage and guide flows based on potentially complex data plane information. Now, what are the specific things that, the way we solve typical problems is what we see, what we feel is not all packets and flows may be forwarded to a controller. So you actually eliminate and, selectively select traffic that needs to be, defined and controlled and secured. So we are able to actually reduce the amount of traffic. You implement several ways to be able to detect anomalies and drop the malicious packets in the switch fabric. So this is like through open flow pipeline and application awareness in data plane. These are some of the techniques that we use to be able to do this. Of course, there are some limitations as well because the data plane itself is prone to some stateful table attacks. And in terms of the network flow visualization, we do try to scale them vertically, concurrent processing, NF service chain, sharing common operations, etc., to be able to provide kind of a scalable solution. And then finally, we actually integrate this into SDN stack. And within a switch, we're able to create a logical chain of different app modules, kind of like microservices, you could say, for each flow that requires a network service. This is another very, very big area, artificial intelligence and its application security. In fact, there's nobody now that does not work on artificial intelligence. So basically, we are looking at a lot of work here, and I'm only sharing with you a couple of pieces of work here where machine learning, is used to develop an intrusion detection system. Both of these papers are in IEEE access, and to be able to detect the cyber attacks at a network level and a host level in a timely and automatic way. And the problem with really studying these types of things are, one, the data sets that you use. What are they? How good are they? Do they really allow you to make decisions or conclusions that can really apply to other scenarios? These are the types of challenges. So mostly in the intrusive behaviors, you can see intrusion detection classified into a network-based intrusion detection system or a host-based intrusion detection system. And here in this pieces of work, they've actually combined both of these types of intrusion detection behaviors and looked at deep learning approaches to model the cyber attacks proactively. So there are definitely some deficiencies. Obviously, like I said, data sets are very, you could say, subjective to many limitations. And, but this is very, very extensive work, and you're welcome to please look into it very in detail to be able to understand the various different outcomes that they have, these set of researchers have arrived at, looking at how you can do advanced text representation methods, especially using NLP to explore host level events, etc., using various benchmark data sets. In fact, they've done a very good exploratory work looking at very many data sets on comparative experimentation. They've also done a scalable hybrid intrusion detection framework, which is called as a SHIA framework to introduce processes to process actually large amount of network level and host level events to automatically identify malicious characteristics. Lastly, from a research perspective, what I wanted to mention is this is, again, a very new area looking at blockchain-based platforms. You hear about blockchains a lot, I'm sure, these days. And in this application, we are looking at how can blockchain be used for critical infrastructure protection, where, again, performance, energy, security are all critical. On the one hand, we have resource-constrained devices to operate for longer duration. On the other hand, we need to actually perform operations. And so we are able to actually look at what are the pros and cons of actually having decentralized networks within the blockchain framework, and use lightweight and performance efficient platforms to be able to solve this. So that brings me to the end of the kind of an overview of some of the research activities. Here is another piece of major work in terms of really developing an in-house IoT platform, wherein we've looked at building middleware, big data framework, etc., within the research expertise here at our group, and also building actual hardware, you could say, devices, IoT sensors across the board. So these are all great outcomes that have come out of our lab. And then I want to switch on to another major area that is of high importance to us as well, which is really education. And here we've done so much of it. And actually this conference is also a potential outcome, you could say, of the tremendous work we've done. We train not only our Amrita students, but we've done a large amount of nationwide outreach. We're also kind of pioneers of game-based learning. We actually have trained several K-12 schools as well. And actually the objectives have been, how can we really give hands-on experience in really learning cybersecurity. Additionally, we also care a lot about cyber safety, cyberbullying, internet safety, and hygiene, etc. These are just broad areas where a lot of cyber education and impact has been made from our center. And these are the, you could say, recent CTF achievements where our students have really, the numbers on the left side and the right side really indicate the ranking our teams have got in various different international CTFs. Again, a commendable job in terms of really performing at an international level. And what has all this resulted to? If you look at this graph on the left side, it shows Amrita's ethical hacking team and its worldwide rank, how it had crept up from 2014, being around 250th world rank to up to 20th world ranked in 2019, end of 2019, beginning of 2020. And this is by a ranking agency called the ctftime.org. You see below, and it actually, the Amrita team has been the sixth amongst all academic teams as well. So the ctftime.org actually ranks both professional teams and academic teams. And our countrywide rank has always been number one. So our students and our faculty have really put together programs to be able to do this, and various other achievements. In addition to that, our students have been very prolific in terms of really looking at bug bounties, tools, talks, CVEs, etc., and even been recognized in various different halls of fame. And I'm just going to run this through. These are all work by our students, so I really appreciate what they have put out in open source for all of you to take a look at, to learn from it, to use it in any way you like. Primarily for education purposes, how you can really study various different the disciplines of security in a very effective way, especially if you're a beginner. So that really just brings me to the aspect of really the options that we have at Amrita in terms of various different specialties, what you can do on campus, what you can do online. These are the URLs that you can take a look at. And with that, I wanted to really also emphasize the institution that we are part of, Amrita Vishwavidyapeetham. We have 6 campuses across the country, and in terms of where we are, in terms of various locations that was it. And finally, how are we recognized as a university? Today, if you see this graph, we are recognized as the 4th best university in the country. We've also been granted the Institution of Eminence status by the Government of India, and various different international rankings by ranking agencies. With that, I'd really like to thank everybody for listening to this short talk and a quick overview. And I know we are kind of running short of time. So I'm happy to answer questions, but you can just email me or you can just put it in the chat. I don't want to take away time from our next speaker because it's a very exciting topic. So Purnima, if you can just please collect those questions, and perhaps later we can definitely address them. Thank you again.
Thank you, ma'am. Thank you so much for sharing our vision and mission here at our Amrita University, along with the different research development by our faculties and students of our department with all our participants. So as ma'am has mentioned, if you have any questions, please do drop here in the chat, and as well as please do feel free to contact us regarding the various programs and our research works at Amrita Vishwavidyapeetham or at our Amrita Center for Cybersecurity and Networks, and we will be very happy to help you out.